Welcome to the CAD session for version 3 of the play car. This play car exists in two different iterations. So the first one having e-bike controllers on the electronic side, and the second one utilizing hoverboard electronics. Otherwise they are very similar. This is the design for version 3 and builds on the same principle as version 2, with like a front and a rear half of the car that is then glued together with some kind of strips of sheet material. The size of this car is bigger, and the reason for that is that this car is made to be an outdoor use car, and instead of the 360 millimeters wide version 2, this one is 410 millimeters wide, as well as around 800 millimeters long. So why this size in particular then? There are many considerations when thinking about the performance of the car, the ground clearance, the ride height, the wheelbase size and the stability at speed and so on. But there are also considerations like what kind of system can print the parts needed, and how accessible are those systems. So I decided on the 410 millimeters because there are cheap bed slingers that have an XY build area of 420 by 420. So the 410 millimeter width together with some brim to increase platform adhesion has been one of the limiting factors to how big this car has become. Then I want to address different things from version 2 that were problems. And the first one, given the performance and speed of these cars, is the ride quality. So in the previous version of the car there were pieces of the hoverboard frame that were cut to salvage the motor fastening interfaces, and those were then just bolted to the printed body. In this case they are instead bolted onto swing arms like this. Only the left one is pictured here for visibility purposes, and then there is an axle going across the car here where the swing arms pivot. This body up here represents a TPU body that acts as a shock absorber when the wheel is hitting bumps. So this has been working fairly well, and the TPU part can naturally be tuned by more or less infill or infill type and shell thickness, etc. to provide more or less dampening. In addition to the dampening in the rear, we have a dedicated seat for this car, also intended to be a TPU print. It has this kind of like a lock-in place interface that works thanks to the flexibility of the TPU, that you can just make it snap into place and then it will stay there. And also here it can be tuned with the amount of infill and shell thickness to provide a softer or harder seating experience. In the front I utilized similar principles as version 2 for the front assembly, resting on the durability of wooden rods like this. Had some additional wooden rods from the upper part of the chassis here as well. This larger printed part here is just consolidated parts instead of separate fork parts. There are now one bigger part taking care of more small things, so less parts to assemble. But being a rigid assembly, the front part of the car didn't provide enough dampening for riding on rough surfaces. I moved to a larger rim and a slightly thicker tire, but it was not enough for where this car ended up being driven. So I had to come up with some additional solution to make the car a little bit more pleasant in the front, and the solution was to make this kind of tire that had a lot more dampening than the previous version. And that approach has worked really well, and it basically solved the ride quality issues for this car. So it has been a good ride, and it has been utilized a lot. Another thing I mentioned for version 2 was the Ryobi power tool batteries. I had two of them in the back of the car, and that had some pros and many cons. So in this version I opted for an internal battery placed in a better position weight distribution wise. So this is a lid, and beneath this lid is a compartment for a custom made 10S3P battery made out of 18650 cells together with some 10S BMS. And then here is the charging port directly salvaged from the hoverboard to utilize the hoverboard charger for just plug and play charging of the car. And also being 30 cells as opposed to 20 cells that were in the two power tool batteries in total, having a much better range of the car as well as better current handling. Underneath here there are fastening for e-bike controllers. For iteration 2 there are also these fastenings holes here for the hoverboard electronics. Then naturally, like all the cable routing necessary for the motors, also for lights here in the front if that would be mounted, flick switch for the lights, and then up to the hand controls on the handlebar here in the front. So all of those things similar to version 2, just a little bit more refined. This tire here, it is the tire, the rear tire that was also used in version 2. When that one had the remade rear tire, and that one was then used in the first iteration of version 3. But there is also this tire that is slightly wider, a little bit larger diameter, and has some more cushioning as well, that is utilized on the second iteration of version 3. Not a big difference, but a slight improvement in both top speed and also ride quality for that rear tire. Another flaw with version 2 was the steering components that protruded slightly underneath the car in this area. And for this version, all of the components they are now tucked away up above the wooden rods in the front, which is a simple but very useful improvement to the overall design. The biggest flaw of version 3 of the Play car has to be the steering column. So on my quest to make like solutions that are easier and easier to assemble and not require any like metal work or other complicated mechanical operations, I opted for a solution that would squeeze around a threaded rod. So in the steering head there is a fairly long threaded part, as well as in the steering arm. Then there are these holes for bolts and nuts, and there is a gap in the steering head here. So when you tighten the bolts and nuts, the thread in the steering head will then squeeze around the thread of the threaded rod. And I figured this would be a fairly good solution, and the surface area would probably like provide enough force or torque. But later on it turned out that it wasn't sufficient. It wasn't providing enough torque. So it's no problem when the car is being driven. But when the wheels are stuck in sand, for example, in a standstill, and a lot of force is being applied to the handlebar, or when the wheels are at its maximum steering input and the handlebar is pushed even further, then it can slip at the steer column, either in the steering head or down in the steering arm. And the result of that is that the wheels are of course misaligned to the handlebars. So very inconvenient, and a grown-up needs to come and realign the wheels to the handlebar. While this car was designed to be very functional and primarily improve the flaws of the earlier generations, I think it falls a little bit short on the aesthetic side. Now I want to show the live versions of version 3 of the car. And as mentioned, there are 2 iterations. So here we have the most recent one, the one with the hoverboard electronics, and here we have the one with the e-bike controllers. And just for good measure, I brought out the version 2 car just to reiterate the size difference between these cars. Let's have a look at the differences between these 2 iterations of the car. So this one having the e-bike controllers, it's still being alive and ready to go. And one of the benefits with the e-bike controllers is that they come with, for example, like a half twist grip throttle like this. And that, with the right settings put into this, you have a good speed indicator, you have an odometer, and also battery charge level indication. The downside of e-bike controllers is that they are quite like violent from zero. So I was just carefully twisting the throttle there, and the car jumps away instantly. And I have noticed that different e-bike controllers are a little bit different, and they could probably be reprogrammed some way, but the settings that are like accessible through this display, they can't do much about it. I have tried that extensively to see what can be done. Then another downside with e-bike controllers is that the e-brake is very weak at low speed, and then picks up more and more as speed is increasing. The driving characteristics of e-bike controllers is a little bit jerky compared to how the reprogrammed hoverboard controller works. And I can demonstrate that by starting the hoverboard controlled car and just pushing the throttle like this. Like extremely smooth and proportional control. And it also has other features due to its customizability. So a double tap on the brake will activate reverse. Same thing there, like very smooth. And even though it's extremely smooth, it's not weak. Push full throttle on this one, it will burn out, no problem. However, there are not only like advantages with the hoverboard controller and this car in its current state at least. naturally there is a bigger hurdle to recreate a car with a reprogrammed hoverboard controller as opposed to just slapping on a pair of cheap and accessible e-bike controllers. But there is also things that doesn't exist on this car, like a battery indicator. Even though that can be added with the hoverboard controller, it's not present in this iteration. So I also want to mention that the hoverboard, like Logix, the program that I have used to reprogram this car, I have found on GitHub, and there is a person called Emmanuel Ferro that has a repository called something along the lines of hoverboard firmware hack or similar, and there is a sub version under there called hover car. And the hover car program is what I have used to put into this controller in this car, which sits in there now. However, I found that the controls, especially the brake controls and the brake logic, was lacking. So the brake was way too aggressive, and it would lock and oscillate the wheels around the zero position. So I have gone further with this program and also added new logic to have separate current limitations for the brake as opposed to the throttle, which has improved the driving experience even more. Then things that wasn't shown in CAD, like the damping in action here, for example, the squishiness of the seat, also another thing, the damping of the front tires like this, all things that provide a much better riding experience with version 3 over version 2, and those things are very similar for both iterations. Yeah, the rear tires are slightly different, these are a little bit more spongy than those, but overall it's the same mechanical setup. I think I showed this interface here, and the odometer says almost 200 kilometers driven for this particular car, and that throttle wasn't on the car when it was completely new. So I used another thumb throttle in the beginning, but my children complained it was a little bit too hard to push the throttle, so they got tired in the thumb with their small hands. So I switched to the half twist grip, and I think it's safe to say that we can add like another 100 kilometers or so. In total, between these cars, they are probably approaching 500 kilometers driven, and I think that's wonderful. It's proof that it's a robust design and it works very well. And here is my daughter Iris driving the version 3 iteration 2 hoverboard electronics car. This is a local bike track where kids from the area can play around with bikes or kickboards or cars or whatever, and we have had a lot of fun here testing the cars out. It has gravel and sand and some banked corners, and even some jumps if you go fast enough. Here's another clip of my second daughter Luna, and she is taking a path through the small woods here, and I'm running and trying to keep up with her. This is the highest setting of the version 3 iteration 2 car, and it's pretty fast. And here is me on one of many runs together with the girls. driving the play cars. Nice activity for us together. Alright, that was version 3. Quite an improvement over version 2. But version 3 does not represent the end of the road. There is also version 4 already in operation. And in the next video I will cover the design and the ins and outs of version 4. And if you are interested to follow along on that journey, this is version 4 shown beside the second iteration of version 3. So stay tuned for that, and thank you for watching.